Hi, it's Mark Graban again. Here is some additional bonus material we didn't have time to cover during the main webinar that I did for KaiNexus titled How to Use Process Behavior Charts to Improve Case Studies. So this is the second bonus material video. The first, I called it the bonus round video, covered how to use process behavior charts to do comparisons of individuals or groups or organizations in a snapshot in time. Here in what we call the mega bonus round, here's bonus content video number 2. We're going to talk about how to use process behavior charts when we've got increasing trend over time, not just a metric that's fluctuating around a horizontal average. What if we have something where the default, the baseline is a linear increase? Can we find noise within kind of that general trend? It's not going to increase in a perfectly linear way. So when we start seeing variation around that trend, we can detect signals and not get confused or not overreact to the noise. So in my book, Measures of Success, we use an example from KaiNexus where the number of marketing leads was going up in a linear way, and we were looking for variation around that. Another data set that I found in the news was about life expectancy. There was a headline, you can see here, US life expectancy declines again, a dismal trend not seen since World War I. So again, well, that's an interesting comparison, but does that mean recent trends are really a signal? Here's a little text from that article. It says life expectancy declined again. This has been the longest sustained decline in a century, an appalling performance not seen in the United States since 1915 through 1918. And that was a combination of influenza and World War I. But let's take a look at a longer term context. Here's a chart that shows US life expectancy going back to 1960. So it's gone up quite a bit since then. But what about some of the sub-trends or the longer-term trend? If we go back to the 1960s, we can draw a process behavior chart that shows it looks like it was just kind of fluctuating around a flat average of or just a little over 70 years. And because that's a predictable metric, we would have used, in 1968, process behavior chart to predict that, well, it looks like unless something changes, it's going to continue fluctuating around that average. Except thankfully, it did not. Life expectancy started going up. And we see here clearly, for one, we see in 1971 a signal, a data point above the upper natural process limit. Given 8 years, we see 8 consecutive years above the old average. This is clearly no longer a predictable metric. It's not fluctuating around a flat average. We can draw a form of process behavior chart where we see, here we go, that it's fluctuating around a linearly increasing line. Some data points are above that diagonal line, some are below. It's fluctuating within this newly defined realm of noise. So if this were now the predictable system where it's predictably increasing at a linear rate, we would extrapolate that. So we would have expected it to keep going up around the green diagonal line and stay within those red limits. We would have gotten to 2017 with a life expectancy of about 84 years, it looks like. But unfortunately, from about 1984 on, here's what happened. That increase leveled out a bit. It's still increasing, but just not as much as it had been from the late 60s to the mid 80s. So we would have seen actually all of our different signals. We would have found a point below the lower limit. We would have seen 3 out of 4 closer to the limit than the average. We would have seen 8 in a row below the old green increasing average. So it's leveled out to increase of a smaller slope. So if we zoom in and look at this decade from 2010 on, it looks like it's just unfortunately fluctuating around a flat average of about 78.7 years, not up at that 83, 84 that we would have seen if the increase had continued. So going forward, I guess the process behavior chart predicts that life expectancy is going to continue to fluctuate within, this is a fairly narrow range of about 78.5 to 78.9 years, unless something improves in the system, the really broad life system that leads to life expectancy. We would see a jump up. We would see hopefully some improvement to medicine or technology that puts life expectancy back on a diagonal track. But again, stepping back and looking at the longer term trends, and here I guess, badly sketched out where those limits would have continued increasing. 2016 and 2017 may have appeared to be a signal where we have a point below the lower limit. So we had a lot of examples in the webinar here related to emergency room visits, traffic deaths, life expectancy. Let's step back and look again at something fun. The MBA and the increase, I think a pretty clear long-term linear increase in the number of three-point shots taken from 1980 when the three-point shot was added to the MBA, the 2014. There's that increase, and then there's a period of 3 years where it took a jump up, and then it jumped back. It deviated from that linear increase. And so when we see a signal, we hope we can understand and find a reason why. And I think there's a really clear difference in the MBA those 3 years. That's having 3 seasons with a shorter three-point line. The three-point line was moved closer to the basket. The number of shots taken beyond 3 jumped up, and then the NBA adjusted back and moved the three-point line back. And it's interesting to see in the context of the linear increase, it jumped up, and then it jumps down. So that's an example where we can use process behavior charts in a setting where it's not just fluctuating around a horizontal average. We can look for noise and signals in the context of something that hopefully continues increasing around a diagonal line. So that is it for the bonus content. I would like to thank you for watching it. I want to encourage you to go check out the full webinar and the other bonus video. If you want to learn more about KaiNexus, you can go to KaiNexus.com. If you want to learn more about my book, Measures of Success, you can go to www.measuresofsuccessbook.com. Thanks.